Okay.
So so for the Y of this arm to start waving, you have to make it so that, because I had it so that if the Y of the arm.
Wait, 1 second. I just realized, is the arm defined by a line?
Yes, the arm is defined by a line.
Okay, so you have a fixed XY on one side and the other side.
X on one side and then the Y is changing.
Got it. Okay.
And so I'm saying if the Y is less than this point right here, then you can move it down. But if it's greater, if it's otherwise, then move it. Well, actually, I said if it's equal. After that, I said if it's equal to that point where it stops, then move it up. But the thing is with that, then as soon as it starts moving up, it realizes, oh, I'm above the point again, so I can start moving down again.
Okay.
And so it just jerks like.
So how do you tell it to keep going down once it's below the spot?
Yeah. So what I did was I came up with a variable called arm type, and I said up or down. And when the arm type is down, then the arm position adds 1 to it, and the Y adds. And if the arm position, the Y, is greater than 290, then the arm type is now up.
Okay.
And if arm type is not down, then that's what the else is. Then if arm type is up, which we changed it to up here if it's greater than 290, so if it's like right here.
If it's, up is the top point?
If it's going up.
Oh, if it's
that's
going up.
That's what it means.
Okay, got it.
I can do arm direction, which would be a little bit more helpful, I think. But, for reading the code. But anyways, and so I said if it's up, then move it up, and then move the arm up. And if it's less than 260, then make it go down again, which makes it, once it runs through it again, it says, okay, now I'm going to move it up. And then I'm going to move it, then I'm going to move it down.
When the arm type is less than 260, it's changed to arm type down.
Which means that it's going to go down, because then it runs this, which says that arm type plus plus.
Because if it's down, it needs to go up. Got it.
If it's down, it needs to go up and up all the way before it changes.
Got it.
And so then we have this basic just drawing the snowflakes. And Jonathan prompted me to do this, so I'll restart it and just show you. It takes a little bit of.
So how do you do time in here?
Time?
How do you have it be a certain thing for a certain amount of time and then change
I created a variable called time, and I used that variable to say every time, so there's a function every 60, it's called 60 times a second for my browser.
Okay.
Speed. And if time, so it adds 1 to time every time this is called.
Every time it runs through that.
So it adds 1 to time 60 times a second, which basically means that every time is 60, every single moment that time is 60 is divisible by 60.
Okay. Every second then.
Yeah, every second. Then time will be 1 second. Well, never mind. So, sorry, it's kind of confusing.
So there's time. Can I scroll here or does it mess things up?
You can scroll.
So, maybe not.
Well,
I can't scroll
you
there.
can use.
So, you define the variables at the beginning, and one of the variables is time.
Yeah.
And, because otherwise it is what it is. It doesn't change.
Yeah.
Is that right? Okay. So, now you said at a certain time we're going to have it be white. But no, it doesn't even matter what order you put it in.
It doesn't even matter what order I put what in.
The title screen.
Oh, this title, if I put this up here, would it change anything? If I put this in,
We have snowflake prototype. We have the thing. You have the equations to draw the snowflake before you have the title screen, but that doesn't matter because
it doesn't matter. I could put, but just as long as this loop is after this, because it refers to it right here.
Gotcha.
And so
Gotcha.
it has to be after that. But otherwise, you can just mix them up in any order that you want. And the draw snow is what makes the bottom white go up, the white part go up. And then once it's all the way at the top, it waits.
Oh, does it increase? I didn't notice.
Oh, yeah, it does.
Oh.
I can show you.
I thought you weren't doing. Yeah, restart. I thought you only had a solid bar of snow on the bottom.
I had a solid bar of green, and then
Oh, right.
And then he was like, "Oh, if you change it to going up, then that would be cool." And so I created another one called rect height, the rectangle, the height of snow,
Uh-huh.
and I use that to say, you'll notice it'll start going up.
Gotcha. So it doesn't start until the snow hits the
It
bottom.
doesn't start until the snow hits the bottom, and I said that by saying the original equation that loops them back to the top. I use that to say over here, right over there. I used it to decrease the rect height, increasing the snow level. That's what I used to make it go up. And then up here, I realized that it wouldn't. I actually had to troubleshoot this part because originally I didn't have the draw snow, which is basically just fill and then a rectangle.
Mm-hmm.
I put all of that code just down here.
Yeah.
But basically then only when a snowflake passes the bottom and gets looped back to the top will it show the rectangle. Otherwise it'll flash the green on top. Otherwise, because it just flashes. Because everything is getting drawn multiple times.
Right.
But that's only getting drawn
Right.
once. And so I had to create a function that gets called the draw snow. It gets called down here.
Mm-hmm.
And if the draw snow it uses the snow, it bases how tall it is based on the height of that.
It says how tall the white is.
Look, yeah, it says how tall the white is.
There we go.
So we were at the drawings. The snow says it refers to the rect height to see how tall the snow is. And all that I'm doing here is just increasing it. When a snowflake passes it, I'm just increasing it by 0.5,
Okay.
which is basically what makes that snow happen.
And then how does it know when to stop?
How does it know when to stop? I said if the rect height, the snow, is greater than or equal to 350, so basically while the snow is at this point or higher, then you can subtract from rect height. Otherwise, do not subtract. Otherwise, it'll just go up the whole screen, and that would not be good.
Wait. Say it one more time. While the rectangle height is
No, if because otherwise
if it's greater than 350, is that
greater than or equal to. This is 0, 0.
Okay, great.
This is 400. This is
Show me this. What to do? Here.
the top left corner is 0, 0, 0.
I can't switch it around now, can I?
No, it's good. The top left corner is 0, 0. The top right corner is 400, 0.
Okay.
The bottom left corner is 0, negative 400 is 0, 400. Sorry, and this is 400, 400.
So 0, 0.
So this is 0, 0.
And this is negative.
No, that's not negative. This is positive 400.
Oh.
This is positive 4. This is 400, 400. This is 0, 0.
Okay, so it's not like a coordinate plane
It's not
normally.
like a coordinate
It
plane
starts with 0 and it adds
Starts with
positively.
0 and it adds positively to both.
And how does it know that this spot is 0, 0? Is it because you only have this square to work with Khan Academy?
No, I can change the width and height of it by changing the URL, or there's a settings thing that can go up to 600 pixels by 600 pixels. Right now it's 400 by 400, but if you add into the URL a question mark width equals whatever and then height equals, then you can change the height to whatever you want and the width to whatever you want.
Okay, so basically this, how would you put this somewhere that was not in Khan Academy?
How would I put all this code?
Yeah. Do you know?
Yes, I could just use any browser or any processing JS coding platform would support this, because this function that draws all of it, the draw equals function that calls it multiple times a second, is only supported in processing JS, because processing JS is made.
JavaScript. JS?
No.
Oh, processing JS.
Processing JS is different than JavaScript.
Okay.
Because it was originally made to make graphics and animations.
Yeah.
And so it has a lot of tools like circles, ellipses, and
Okay.
there's a lot of tools to make graphics and animations.
Okay. So could you go into a new Chrome screen and copy and paste it somewhere?
The code?
Yeah. Could you, like when you go
In a new website?
Yeah.
If it supported processing JS, yes, but a lot of the text editors on the Chrome Web Store are blocked for LCPS,
Gotcha.
and I can't find any websites that support it besides maybe this, but I'm not sure if that's processing JS.
Okay.
Yeah.
So basically you need a web browser that can process
That can do processing JS.
JS. Okay, awesome. So you have the rectangle. Where was that rectangle? Snow height.
The snow height, the drawing part.
Draw snow.
Yeah,
This
let's
one?
draw snow, and it's defined up there.
So first you have to say if the time is greater than 9:30, because that's when the first snow hits.
No, that's when the snow is all the way up to that top part.
Oh.
Then you can start drawing the snowman.
Oh, gotcha. Oh, so you don't want the snowman to be drawn until the white is all filled up. Okay, wait, where's the snow though? The rectangle height, right here. Here's draw snow. So if the rectangle, no, where's the one where it's greater than or equal to? How do you make it fill? It's down here?
Mm-hmm. It's at the very bottom because that's where I draw the snowflakes. And I didn't want to have to add code, so I just used, developers are lazy, and so I just used a previous thing that I used to loop the snow around to
add to it the snow.
height.
Okay, got it. So if the rectangle height is greater than,
Yeah, the snow height is greater than or equal to 350.
which means,
350.
yeah, that's 350. So that means there's snow all the way from here to here, because it's greater. That's kind of, okay, it's hard for me to wrap my head around.
Yeah, it is. I had to.
All right, if the rectangle height is greater than 350, then we know that it's full.
No, if it's greater than or equal to,
Yeah.
if it's equal to 350, then we know that it's full. Because originally, this is 400. This is the 400 on the y-axis.
Uh-huh.
And I originally draw a rectangle that's just from
It starts at 400.
400, and then it has a width of 400 and a height of 0, or a height of rect height, which starts out as 0. And then, as it says, while it is, if it goes down, then if a snowflake passes the 410, because this top, all of the lines, you'll know there's a line.
A snowflake is y greater than the 410. Got it.
Then you can loop it back to the top, loop the snowflake back to the top, and you can also say if the rect height, so the snow, is greater than or equal to 350, so while it's in this range, then you can subtract from, which makes this go up in subtraction.
Because rect height is the green or the white, or
Rect height is the white.
okay, wait.
So
So
the green is never changing.
it's just getting covered,
It's just getting covered because I can change the green,
but you don't have to.
but I don't have to. I'm just changing the white because that's how it happens in nature. I figured.
That's cool.
No one's gonna read the code, but I mean.
Right. So if the I'm just trying to understand the coding. So if the rect height is greater than, and the rect height is like at the beginning it's 400.
At the beginning, it's 400, right?
Rect height is 400. It's because rect height is a y value. It's not a measurement. It's a y value.
Yeah. The height of the rectangle is defined in the third parameter, which is height.
So the rect height, if it's y value, if the y value of the snow is greater than or equal to 350, then you keep adding. But once it's at 350, the rect height would no longer be.
It would no longer go up, so that it doesn't envelop the whole screen in white, which would not be fun.
Which would not be cool, yeah. So if it's greater than 350, then it knows to stop adding 0.5. Okay.
I also do that. Which, I mean, oddly enough,
So really it's 350 point, or 349.5, because at 350 it adds a one more, right?
at 350 it goes up, yeah.
Because if it's greater than or equal to 350,
so, yes.
then it will add 25.
So it will add at 350. So it ends up.
How does that know that it's adding 0.5? The curly bracket, like.
Well, this right here, the curly bracket.
How does it know that it's adding 0.5 as opposed to changing it to 0.5?
Because if I was changing it to 0.5, then I would only do equals. Minus equals means that you subtract that much from it.
Oh, there's a minus in
Yeah, there's a
there.
minus.
Equals minus.
Yeah, if I just did equals, then it would set it to 0.5, which would make it go all the way up to 0.5, which is right at the top of the screen.
Gotcha. Okay, so now it's subtracting 0.5 from that value.
And since it's not like the coordinate plane, it goes up.
Got it. So it's 350. So if it's equal to 350, one more time it's going to subtract 0.5.
So it's
So
going
it
to
ends
end
at
up at
349.5.
349.5.
Got it. Okay, that makes sense.
And so that's the snow.
That's how the snow grows.
And then in the arm, did I already explain that to you?
You said, yeah, you explained that it's got a fixed right point and the left point. The X stays the same, but the Y is changing. You
Yeah, the
explain how
Y
it
is
goes up and
changing.
down.
Yeah. And it's really simple. Other than that, the snowman is just if
Add
the
an
time,
ellipse.
yeah, if the time is greater than this, then we're gonna add another part of the snowman.
And you
then-
define the ellipse by its center location
Yeah, central location
plus its
plus its width and height.
width, 60 pixels.
Yeah,
So-
60 pixels.
Okay,
So
gotcha.
it's 30 on that side and 30 on that side. And so this rectangle, they're defined by their top left corner.
Okay.
But you can say at the top, if you wanted to, you could say rect mode center, which means it will be defined.
So rectangles are defined by the top left, but circles are defined by the center.
Yeah, because you can't say a top left for a circle.
Unless you have the X or the square around.
Yeah, yeah, that's square.
Gotcha.
That's
And then, so that's how you had the circles. Now tell me the snowflakes. Tell me how you did the snowflakes.
okay. So this was by far the longest part of my project.
Right.
It was. So up here, I defined a constructor function, which basically means that we can build multiple of them. You basically, I shouldn't. Originally, technically, I wasn't supposed to use a constructor function because I'm only drawing them. I'm not making them talk or walk or anything. A constructor function is for making them talk, walk, and do multiple things. But I'm only drawing them. Yeah, but
How do I know it's a constructor function? Is that
because you'll notice that I refer to it down here without a var in front of it.
Okay.
Which means that it's not a variable because it's referring to that, and so it's saying how to draw it. The prototype to draw it is just going to say use the
I'm
X.
seeing that somewhere in some coding. The prototype and the this.x and this.y.
Yeah, I might have. Yeah, it's.
We're seeing that once. Yeah.
Anyways,
So this is the part that says how to draw.
How to draw a snowflake? It uses 4 lines. 1, 2, 3, 4.
And the lines are
Based on the X and Y that you pass in for the snowflake.
so x minus 10 so the point is from x minus 10 y minus 10 to x plus 10.
Yeah, the
y
center
plus
X
10.
where they all meet. And the way that I created is just those 3 lines right there, the for loop, or var I equals 0, while I is less than 800, so I made 800
What's I?
It's just a variable that I created over here to track it.
How many there are.
Yeah, how many there are.
Okay.
And
So
then you add
how
one-
many snowflakes there are for when there are.
And you'll notice that this isn't capitalized, okay? But this
Yeah.
is capitalized.
Yeah.
I created an array up here of snowflakes. So that I could say, so snowflakes, so push a new value onto snowflakes, new snowflake, so a new one of those,
Okay.
and then the X is going to be a random between 0 and 400, and the Y is going to be a random between negative 2000 and 0,
Because
so
the
that
y.
so that it comes down. At random
Because
points.
it's not actually. You haven't told this to. No. You haven't told this to draw and then fall. You've told it to draw at different points. Why are they not showing up all over?
Or they're not showing up all over the screen.
And why does it look like one is going down?
Just this one.
Yeah.
Because only this one is going. Well,
Where's the? But isn't it built? Isn't it created?
it's created at negative 2000 or 2000 up here,
Oh.
so that it falls at a random point, and so they're not all falling in a block.
Because otherwise you'd have just a line of
A
them.
line of snowflakes.
Because really they're being created somewhere off of the screen.
Yeah,
Gotcha. But we can't see them because our screen
it's only 400 by 400.
is defined by, we can only see on the screen from 0, over to 400 and down to 400. But
Yes, you are.
there still exists this space that's not in our
Still
screen.
exist. Lots of
It's
authors
negative
write because they
space.
enjoy
So anywhere between 0 and going up 2000, which is like way higher than it needs to be, right? Like it could just be 400.
It could be 400, but that would make them closer together. You'll notice how they're spread out.
Okay.
See, look, if I make this negative 400, when it starts coming down, you'll notice that they're a lot closer together.
Oh, gotcha. So because you wanted to have 800 snowflakes, they're spaced.
And while it could work, I just don't like it. I feel like it. I like it a lot better at negative 2000. That's just
Right.
a personal
Yeah.
preference.
Right. Yeah, that's cool.
For thickness.
That's cool. So go ahead and change it back. Oh, and now.
And another thing is, they appear at a random. It's also because I made them appear here when they pass that. They appear at a random between negative 2,000. So even if I change that to 400, it would still.
Don't change it. Change it back to what it was. It was awesome.
Yeah. I mean, now it's gonna be normal.
You had to decide the thickness based on, or the frequency of snowflakes based on the range of where they're drawn, 0 to 2,000.
The range
The
range of where they're created. I didn't draw them here.
Where they're created.
Where I say, okay, now create a new one of these. I'm not.
And then how does it know to fall?
How does it know to fall? Over here, down here at the bottom, I say for the
snowflake.
Just the I variable that keeps track of everything. I is less than snowflakes, which is the array dot length. So basically, the length of the snowflakes array in this case is 800.
If they still had money,
snowflakes in,
first of all,
and add 1 to I every time. So because you have to index it, so you have to put in an index, which is it's kind of confusing at first. So snowflakes, I'm saying access the snowflakes array, and then these square brackets tell you which element to access. And right now I'm saying I because up here we defined I, and 0 it's a 0 index. It's 0 indexed, and so it starts at 0.
Okay.
So if you put 0 in there, it'll access the first one.
Okay.
So I just said draw every single one of the snowflakes that I created up there. That's what that means.
Okay.
And then add 1 to the y. Snowflakes I dot y, and they have
But the
a
x
y.
stays the same.
The x doesn't stay the same.
Oh, but x is random. You're right.
X is random between negative 0.5 and 0.5.
So if you got rid of x, the random part, then it would just look boring and look straight. Can you show me that?
Yeah, sure.
Here, I'm gonna show this. So this is.
It's also really simple because you can just comment out a line.
Oh yeah.
Yeah.
There we go. So that's without the random factor, so it looks like it's just falling, which is, I mean, oops, it's all cool and all that you can make them fall, but it's so much cooler when you change it back to the other one.
Okay.
How did you change it from a comment line to not a comment line?
Except from those dictator
2 slashes.
Okay, 2 slashes. And so now they're wiggling back and forth, so it looks like more real movement, like snow would actually look.
I can also
And that was something you figured out how to do.
Yeah, I can
because
also
it wanted
randomly
to
change
look more like snow.
I can also randomly change the y a bit, but that kind of makes it jerk.
Yeah.
I could add a couple of lines of code to make it not jerk if I wanted to, using a function that I recently learned. It's called noise. It doesn't make noise.
Well, no, it adds some quote unquote noise to the value.
Yeah, it makes it smoother.
What makes it smoother?
Yeah, it'll make it smoother if I made the y random.
Yeah.
Then I would make it.
Oh, if you put random and noise in there.
It's kind of it takes a lot of time to understand it.
Anyway.
And then I say if it's greater than 410, greater than or equal to 410.
Yeah.
Basically, if it's down here,
if the
then
snowflake is down
move
there.
it back to a random between negative 2,000 and 0. So you
Gotcha.
can never predict exactly when they're going to fall because it is a random. It is random.
So it is actually, yeah. So it's not a same thing that repeats
it's not,
itself.
It's not a random repeating pattern of 800 snowflakes. It's not random repeating of 800 snowflakes. It's changing every time.
I finished my lemon ginger.
That's so cool.